Retrieve the acid dissociation constant, Ka, or pK of values from the table. According to the provided data table for haloacetic acids, fluoroacetic acid, Ka equals 2.57 times 10 to the power minus 3, or pK equals 2.59. Chloroacetic acid, Ka equals 1.35 times 10 to the power minus 3, or pK equals 2.87. Relate Ka and pKa to acid strength. The acid dissociation constant, Ka, quantitatively measures the strength of an acid in solution. A larger Ka value, which corresponds to a smaller pKa value, indicates a stronger weak acid because the equilibrium lies further to the product ionized side. Comparing the two, fluoroacetic acid has a larger K, 2.57 times 10 to the power minus 3 greater than 1.35 times 10 to the power minus 3, and a lower pK, 2.59, less than 2.87, meaning fluoroacetic acid is a stronger acid than chloroacetic acid. Connect acid strength to percent ionization. Percent ionization is defined as the ratio of the equilibrium concentration of ionized acid, H to the power plus, EQ, to the initial concentration of the weak acid, HA0, multiplied by 100%. Percent ionization equals H to the power plus over HA times 100% for weak monoprotic acids at equal initial concentrations. Both are 0.10 molar in this scenario. The stronger acid will dissociate to a greater extent, yielding a higher concentration of hydronium ions, H to the power plus, at equilibrium. Consequently, the stronger acid will always exhibit a higher percent ionization. Compare the percent ionization of the two acids. Since fluoroacetic acid is the stronger of the two acids, it ionizes to a greater extent than chloroacetic acid at equal concentrations. Therefore, the percent ionization of chloroacetic acid must be less than the percent ionization of fluoroacetic acid. This directly aligns with option B. The correct answer is option B. The percent ionization of chloroacetic acid is less than that of fluoroacetic acid.